blocks in here also. Two level switches from the DI water tank go to terminals 40 and 41. The two switches for the RO permeate tank go to terminals 42 and 43. So 4 terminals all next to each other in the terminal block strip down here where all the level switches are wireless. Now let's review some of the alarms. We've got, as you can see, in our 6 red lights here, 2 red lights here. 2 here are similar in function. They are both what we call fault lights. These indicate some kind of power problem in the system. You'll notice this is the switch to the feed pump, this is the indicator light for the feed pump, and this is the motor fault for the feed pump. If for some reason the EDI feed pump is drawing excessive current and the overload contactor trips, this light will come on. I think we can simulate that here by tripping the first breaker inside here. And you'll see that alarm light comes on. If that happens, you can reset it very easily. The reset button on the right here, this little blue button on the overload relay. With that, light will go out. But you should check to see why the excessive current is drawing. Usually there's some problem with valve closed, or there's a voltage problem, maybe low voltage. There's some issue. If you restart the system, you'll have to hit the blue reset button on the contactor. You'll have to hit this reset button here. And you notice I hit the reset, now the system's starting up again. That's what this reset button is for, to clear any kind of alarm situation. DC power supply fault, similar function, but instead of looking at the EDI feed pump, this looks at the EDI power supplies in this panel. For some reason, one of these power supplies over here draws excessive current. It will trip an overload relay over here. And I'll just pick one here. Now, red light is on. We have a DC power supply fault. That's one of these contactors. Again, there's a little blue button here. It says stop reset. You can see that this is tripped by this little yellow light right there. That's indicating that it's tripped. You reset that by pushing the blue button, and then the little yellow light goes out. And you'll see the light now is out over here. The system, however, is not restarted. You see the red light is out, but the system is not restarted. The reason is I've not pressed the reset button. If I press the reset button, now the system will start. While it's opening, soon this green light will be on and this green light will be on. So that covers these 2 faults. Feed pump motor fault. We have a contactor in this panel, which trips to reset, hit the reset button. DC power supply fault. Any of these 8 power supplies can trip. Any of them trip. Reset the contactor in the cabinet, then hit the reset button, and then you're running again. Then we have these other 6 alarms over here. We do have one more fault light. Let's review that here. This is called the valve fault. We have a similar light on the RO skid which we reviewed before. If the system tells this inlet valve to open, it will examine the position of the valve, and if the valve does not go to a full open position, you will get an alarm and the system has stopped. If it tells that the system wants the valve to close, it will examine the position of the valve. When the valve does not get to a fully closed position, you will get a valve fault. So this is just an indication that that valve is not in the position that it should be, and there is some maintenance required, usually adjustment of a limit switch, or maybe see if there's no obstruction in the valve. This indicates that the valve is not in a position that it should be in. The rest of these 5 alarms are indications of the performance of the system. Usually, 4 of the 5 have to do with the feed water conditions. We have these 2, which are very important, which are the inlet low flow and the electrolyte low flow. It's very important that there is flow when the system is running as it's shown now, the power supply is energized. that we have a continuous flow of water through the EDI module. So if for some reason the inlet valve didn't open, or someone closed the valve and the EDI feed pump is pumping but the water's coming in, or whatever the reason might be, if there's no flow coming into the system, one of these or both of these alarms would probably be indicating error alarm condition. The electrolyte is very important. As we mentioned before, we adjust these electrolyte flows down about 0.25 gallons a minute or about 1 liter per minute of flow into each module, for a total of about 2 gallons a minute flowing into the module. There is a switch right here. This is the electrolyte flow. If for some reason the total electrolyte flow for the system is not at least 2 gallons a minute, after about 10 seconds, this will fall and stop the system. Usually everything's working like it should, the flow is like it should. The pump will start, the valve will open, the pump will start, the system will examine the switch and make sure there's flow. If there is flow, then it will start the power supply. If there is not flow, then it will not even energize the power supply and the light will come on. That's a startup. But at any point in time during the system operation, if we were to come and close off all the electrolyte flows, or close the outlet valve, or do something to otherwise restrict the electrolyte flow, we would get this alarm. After about a 10-second delay, the system would stop, and we would have to hit the reset button to restart. Similar function for the low inlet flow. There is a flow switch in the back here, and that checks the flow, total flow feeding into the system. And that's not so precise in terms of the exact amount of flow, but at least to make sure that there is water going through. It's basically a go, no-go kind of switch. There's either flow coming through or there's not. But if for some reason there's not any flow coming through or not enough to make that switch move, we will get a flow switch here. It's not so critical that on the feed that we have a minimum amount of flow, but it is important that we have some flow. It's very important that we have enough electrolyte flow. So this switch is fairly precise, and if the flow drops below this designated rating of this switch, then we get an electrolyte flow. The inlet low flow is just, do we have flow or do we not have it? If we don't have flow, this light will come on and the system will stop. Okay. Then we have 2 more alarms on the feed water condition. One is for the TDS of the inlet water. One is for the temperature. Temperature is an easy one. We have this set up for a maximum feed temperature of 35 degrees C. If for some reason the feed water temperature rises above 35 degrees C, the system will, after a short time delay, the system will stop, give you this alarm, reset. You can reset and start again, but after, if it's still, the water's too hot, after a while, it will stop again. So the solution there is don't feed this system with water above 35 C. The other one is the TDS. Mentioned before, the feed water to this system from your RO system should be less than 20 microsiemens of conductivity, preferably less than that. We believe that it should, under normal conditions, be about 10 microsiemens, but the alarm is set up for 20. So for some reason, the feed TDS is above 10 ppm or 20 microsiemens of conductivity. After about 30-minute time delay, then this light will come on and will stop the system, and you should go see why the RO permeate water is so high. This last alarm is the low product resistivity alarm. And what this is checking is the quality of the product water coming out of the module through this manifold. The sensor right here is checking the final product quality of the DI water coming out. If that water is below about 10 megohm, or in this case we're setting it up for connectivity for your application, being set at about 5 microsiemens. If for some reason this is above 5 microsiemens, then after a 30-minute time delay, the light will go on and the system will stop. And again, to restart, we'll have to hit the reset button. Just to review it briefly, we've got 8 of these red lights. These are critical alarms. If any of these are identified, they will stop the system and have to hit the reset. most cases of these ones here that have a time delay before they stop the system, they will flash on and off once the error condition or alarm condition is detected. For example, if your feed TDS is above 20 microsiemens and it's in the time delay, let's say 30 minutes before it stops the system, for that 30 minutes, this light will flash on, off, on, off, on, off, indicating you have an alarm condition. Once the time delay is elapsed, when the system stops, the light will be solid. These, because there's no time delay, it's an immediate thing that's detected immediately when the device trips, red right away, no flashing, no time delay.
Meters. The meter.
Then we have some instruments. I told you previously we have a flow meter here to measure the total product flow coming out of the system. Here we have a resistivity conductivity meter to measure the feed TDS or conductivity and the DI water resistivity or conductivity, depending on which units you want to use. Over here, we have the control modules for the individual power supplies that power the EDI module. Each EDI module has its own control module. Each control module has two digital displays. One is the voltage, DC voltage, that is being fed to the power supply, to the EDI module, and the second is the current load in amperes that is being measured across the EDI module. So we're feeding voltage and we're reading load in amperes. All these modules and power supplies are set up in what we call voltage control mode. And that means this knob, adjustment knob, can only control the voltage. It cannot control the amperes directly. What we are doing is feeding voltage, measuring amperes. The devices are capable of operating in current control mode where you control the amperes, but that's not recommended for the system. And the proper way to operate this is to adjust the voltage to the recommended voltage and then examine the amperes reading that comes from the power supply and the module. So under normal conditions, the voltage will be approximately 400 volts. Each module is different. Even though they're fed with the same water, TDS, same temperature, they all are various performance characteristics. Some have higher flow and higher rejection, some are lower rejection. They all have, and some are maybe a little more fouled than others, closer to being regenerated than others. They all have different performance characteristics. So as a result, you may have to adjust, when you adjust them, you may take more turns of this knob. Some of them might only take a few turns. You're not going to turn them all to the same position, but you'll adjust each one individually until you get about 400 volts. When you do, then you can see the amperes on each module, and the ampere readings will vary by each module. Some modules will be 1 amp, 2 amp, some will be 3 amp, 4 amp, some will be 5 amp. In general, the higher the amps measured and displayed is an indication of how hard the module is having to work to remove the ions from the water and how much of the ion exchange resin that's in the module that has been exhausted, and which means how much closer you are to having to regenerate the module. There's nothing to be alarmed about that it's higher or lower. It's just an indication. Just because one's at 5 and one is at 2 doesn't mean that this one is doing worse than this one. They're probably both doing just fine. It's just this one's taking a little more power in order to operate. When it does become important, when the difference in the ampere reading becomes important, is when you increase the voltage. Let's say you have it at 400, and you watch amperes go up, 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 until finally amperes will go beyond. The maximum reading is 10 amps. The maximum capacity of the power supply is 10 amps. If the actual load of the module is more than 10 amps, then the voltage will drop. The maximum voltage is 500 volts. So in the maximum capacity of the power supply, you have 500 volts, 10 amps. But if the actual load is more than 10, the power supply cannot do more than that. So to compensate, the voltage will drop, 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 drop. So if you have one module, for example, that is exhausted and needs module regeneration, you might come up here and you might see the amperes at 10 and the voltage at 200, even though you have the knob completely to the maximum position. In that case, you'll have to regenerate that module.
Go.
In the event you need to regenerate your module, you will probably see a condition where the voltage displayed on the power supply control module is lower than what you want. You want to be 400, maybe as the amperes increase, maybe be 450. The maximum voltage is 500. If you can't get there, let's say you're at 300 volts and you have this knob all the way, you have to regenerate. The regeneration is easily done on the system, does not require any chemicals, does not require any special equipment. It can all be done with the equipment. The way we regenerate the module is come over to the front. Let's say we're going to regenerate module number 1. The way we regenerate the module is we increase the concentrate flow to the maximum. We open this concentrate valve all the way up. So we get up here 5 gallons a minute or about 20 liters per minute. We can increase the electrolyte flow also to about double. Get that up to about 0.5 GPM or about 2 liters a minute. We will then cut the feed flow in half. So if we were at 25, now we're going to come down to around 12. So the result of this is we're reducing the recovery by about 50%. The point being that we're putting less water into the system. There's less, as a result, there's less dissolved solids coming into the system, putting load on the module. So why we do that with a high concentrate flow, a low feed flow. While we do that, come over here to the power supply for module number 1, and put that at the maximum. Maybe it won't get to 500 volts, maybe it's only 300 volts. Maybe the amperes are out of range, beyond 10 amps. You do that, and you just leave it there. You'll put it to maximum voltage, 50% recovery. And eventually, the power supply operating at its maximum voltage with 50% recovery will force all the ions out of the solution. It will force the module to regenerate so there's a maximum amount of ionized hydrogen and hydroxyl ions in here that will regenerate this resin, and eventually that voltage will start to creep up. There's a very detailed procedure in the manual for this regeneration process, but in essence what it involves, 50% recovery on the feed flow, maximum voltage on this power supply, and as it continues to run, the voltage will eventually go up until it gets to the maximum of 500. Once it gets to the maximum of 500, then you will eventually see the amperes drop, until finally you can adjust when the amperes get down below 10, then you'll be able to reduce the voltage back down to 400 by adjusting the knob. When you get to the voltage back to 400, you get your amperes will be back around in the 2 to 5 range, which normally is, and you'll be okay. So the process is not complicated, but it could take a long time. It may take as many as 3 or 4 hours for the module to be completely regenerated. You should refer to the manual for specific instructions. Again, maximum voltage, 50% recovery, maximum. After the module regeneration is complete, you come back over here and adjust these valves back to their original position. 25 gallons a minute, or about 100 liters a minute on the feed, 10 liters a minute on the concentrate, 1 liter a minute on the electrolyte. Continuing our discussion on the module regeneration, there's 2 ways that you can do the module regeneration. One is you can continue to operate the system normally and regenerate one module while you can operate the others in the normal mode. When you do this, there might be slight degradation in the permit quality, but product water quality, but not significant. But of course, because we reduced the flow down, you're not going to get as much flow as you were before. You get about half the flow from this module, and all the others are the normal flow. But otherwise, it shouldn't compromise the overall operation of the system. So that can be done overnight. And basically, because we have individual power supplies for each module. So we can put this one in the maximum voltage for regeneration while all the others still stay in their normal mode. That's one method. The other way is we can take the whole system down. Let's say you need 3 modules need to be generated. So you say, I don't see the point of running 5 and regenerating 3. Or maybe you want to regenerate all of them at the same time. That can be done also. Let's just say we only want to regenerate this one. In that case, you could take the system offline, turn the system off, and then come over here, close all the valves for the other modules. Close all these valves for the other modules, isolate so only this module is being operated. You can do that, and then you can come over here and only operate this one for regeneration purposes. And likewise, if you want to regenerate 2, 3, maybe just this one, and this one, and this one over here, you do you open the valves for those 3, close up, adjust the valves for those 3 modules, close the other valve, and you can regenerate just the modules that you want. My experience is that most of the time you're going to regenerate them all about the same time. It's going to take about the same amount of time whether you regenerate one or regenerate all. And usually if the feed water conditions are such that one requires regeneration, usually such that they might all require regeneration. So it's from a matter of convenience, maybe you would prefer to do them all at once, but if you don't want to, you have the flexibility to do one at a time.